Hello, welcome to this video. What I'm going to do in this video is take an example and I'm going to solve it in front of you. We're going to use different concepts of kinematics like acceleration, velocity, time and distance, and displacement, and using that we will evaluate whether or not a certain situation happens, and that pertains to the question. So without further ado, let me get rid of this and start and mention the problem now. Alright, so here's the question. It involves a person driving a car or a vehicle with an initial speed of 30 meters per second, and suddenly the driver of the car sees a poor little kitten on the road at around 80 meters away from the car. If the acceleration of the car is negative 6 meters per second square, we want to figure out whether or not the poor little kitten is unharmed or not. Or that the car is able to stop in between this 80 meters so as to save it from harming the kitten. So we want to answer this question, and for this matter we have involved a poor kitten as well in the problem as well. So without further ado, let's have the solution and let's try to understand how we would approach a problem like this. So the thing is, we know the acceleration and we know the initial velocity. We need to figure out whether or not the car is going to stop at a certain distance that happens to be under 80 meters. So if the car does stop, say somewhere, say the car stops here, this is where the car stops, then at this point where the car has stopped, what does that mean about its velocity at that instant? Well, if the car is stopped, then the final velocity at rest would be 0 meter per second. So that means that our final velocity would be 0 meter per second of the motion that we want to consider. The initial velocity, what we already know, is 30 meters per second. And the acceleration is negative 6 meters per second squared. Now, the thing about this question is the fact that acceleration is given in negative. What does that mean? Well, since the acceleration is the rate of change of velocity in this manner, v final minus u divided by time, then if acceleration is negative, that means your final velocity is less than initial velocity. And if that happens, that means that the car is decelerating or it's slowing down. If the initial velocity is greater than final velocity, which was this case, then the acceleration is negative, but if the final velocity is greater than the initial velocity, then the acceleration would be positive. That's because the numerator turns out to be positive. So what we mean in this case by acceleration with the negative acceleration is the fact that the final velocity would be less than the initial velocity, and it rightly is. The final velocity at rest is 0, which is certainly less than 30 meters per second. So if we know the final and the initial velocity and we know the acceleration which is given to us, then what's left to do? Well, we can evaluate very easily using this equation here, or restating the very same equation as the first equation of motion. We have v, or final velocity, equals initial velocity plus acceleration times the time that taken for acquiring a velocity v starting from u. So that is to say that if we input our values pertaining to this question, that is the final velocity being 0 meters per second, initial velocity being 30 meters per second, and acceleration to be negative 6 meters per second square, and time measured in t seconds, then we can evaluate what time is. So that's very simple. You cancel the seconds from the second square to get meters per second everywhere. We can cancel a meter per second, meters per second everywhere as well. We get a unitless equation of 0 equals 30 plus negative 6 times t. This can be simplified as adding 6t to both sides. We get 6t equals 30. Now dividing everything by 6, or multiplying it by 1 by 6, we get t equals 30 by 6, or 5. What does that mean? Well, that means that the time the car takes to stop is 5 seconds. So we hope that the accident, if there is any, would have taken place in 5 seconds. if there is. If the kitten survives, then we know that even in this 5 seconds, nothing's going to happen to the kitten. So at this point, we cannot say whether or not the kitten would be harmed or unharmed, but we know that the car will for sure stop at after 5 seconds from noticing. So does this really answer the first question of whether or not the kitten is harmed? Well, no, I just said that, but in order to really find what happens to the fact that the car stops within 80 meters, we need to use another property of motion, another concept of motion, another parameter of motion, and that happens to be displacement. And a very convenient way in which we measure displacement is by the variable s. And that is something which is used in the second and the third equations of motion. So our next aim is to find out whether or not the car will stop within 80 meters, or basically we want to evaluate at what point will the car stop at, or after how long, after traveling for how long will the car stop in terms of distances. So to evaluate that, we can get rid of this and note somewhere that the car is going to stop in 5 seconds, which came from our previous use of equation, of the first equation of motion. So we have time to be 5 seconds. That is to say, it takes 5 seconds for the car to start from 30 meters per second with a deceleration of 6 meters per second square to finally reach rest. So it takes 5 seconds to do that. Now, our second and the third equations of motions look like s equals ut plus half at square. Or the other way to say that, or basically the third equation of motion would be v square equals u square plus 2as. So basically we can use either of these two equations to get the value for s. So let's say use the first one. If we use the first one, we get s, which is the displacement. That tells us that the distance would be equal to ut. U is the initial velocity, that's 30 meters per second, times the time over which we are evaluating s, that is 5 seconds, so that's 5 right there, plus half times the acceleration. Remember, acceleration always comes with a negative sign, so we have to write minus 6 meters per second square, and multiply that by time square, so that's 5 seconds square right there. So what we have is 30 times 5, and we get a unit of meters. And from here we have negative, well, this goes by 3, negative 3 times, well, 5 square is 25, and square, and second square gets cancelled with second square to yield only meters. So basically we're getting a value in meters, and in order to evaluate that, we just need to evaluate this. Now 5 times 30 is 150, that's 150 meters, plus negative 3 times 25, that's 75. So that's negative 75 meters. We add these two up, we get 75 meters. Now this tells us that the car would take 75 meters to come to an absolute rest with an acceleration of negative 6 meters per second, or a deceleration of 6 meters per second, which changes the sign. So that is what this equation gives us. Now, you might want to be curious, and you might want to check whether or not the second equation gives you the right answer, and that is a very good thing to do. We can always confirm whether or not the s value is the same. So let's try to get the same s using the other equation of v squared equals u squared plus 2s. Now, clearly, v here is 0, so that yields the left-hand side to be 0 square, and that will be meters squared by second square. Remember, it's measured in meters per second, and when you square it up, you get meters squared by second square. Initial velocity is 30, and that gives us 30 square meters squared by second square, and we have plus 2, and acceleration would be negative 6 meters per second square. And I think I'm running out of space, but we're just left with a variable of s meters. So that's a meter right there. It's a bit hard to see, but the meters and this meter gives you meter square there, and the second square in the denominator. So our final equation looks like 0 equals, well, 0 meters per meter square by second square equals 900 meters square by second square minus, now this is 2 times 6 times s, so that is negative 12s meter square by second square. Now remember, this is a different s in the denominator. Those represent seconds, and this s here represents the variable of displacement, that is this right there. So it's easy to see that the meter squared by second squared eventually cancels out from everything, and you're left with 900 minus 12s equals 0. Now you can solve this by adding 12s to both sides and dividing it by 12 to get 900 by 12. This is the value of s. Now the thing is, what is 900 by 12? Well, it also is 75. What we get here is s equals 75, therefore the displacement would be 75 meters. Remember, we had s to be a variable of displacement. So that tells us that it will take the vehicle 75 meters to come to an absolute rest. So what does that tell us about the Kitten? Well, that gives us good news, really, because the Kitten is at 80 meters from the initial position, and if the car stops at 75 meters from the initial position, we are left with a safe distance of 5 meters. So that should make us happy, right there, to know that the Kitten would be unharmed, unless it obviously chose to move towards the car and ended up hurting itself, or herself, or itself, basically. So that is how you would do a question like this. I hope you understand how we use the three equations of motion of v equals u plus at, s equals ut plus half at square, v square equals u square plus 2as. You also understood the fact that acceleration is negative here because the car is reducing its velocity with every time interval, and also the fact that rest implies 0 meters per second. So there are certain things that this video might have helped you with in terms of understanding motion in one dimension. I hope you were able to gather all that information, and I hope this video helps you in your further understanding of kinematics. So basically, all the best.